Hi, good morning everybody, and once again welcome to Pankaj's Echelon Tutorials. And this today's session is for the IGCSE students. As you can see on the screen, and this is for the IGCSE students. Okay, and the subject that I'm going to deal with today is physics. Okay, and in physics, I'm going to start with chapter number 12 from the David Sang book, the third edition. Okay, the latest one, and the name of the chapter is sound. Fine. So let us get started without wasting time. So in this chapter, in a nutshell, that is in short, what we are going to study that I have listed out first. Okay. So in this chapter of sound, we are going to study what is the origin or the source or the cause of any sound. Sound is a energy like any other energy as light energy, electricity energy, magnetic energy. Okay. So there are n number of energies in the physical world. So sound is one of the energies, and what is the origin or what is the source or what is the main cause of this sound? That is what we are going to start with. That happens to be our first thing that we are going to study in this chapter. Second, after that, we are going to come to how does it travel. So sound being an energy, okay, it is traveling from one place to another place. So how it is going to travel from one place to another place? What will be its speed? Okay, whether it requires a medium or it doesn't require any medium. All that thing we are going to study in this particular subtopic. That is, how does it travel? The third point is what is its speed in different medium. Now sound, when it travels in different medium, okay, what will be happening to its speed, whether the speed will be increasing, decreasing, whether it will be remaining same. Okay, so regarding the speed of this sound, we are going to study in different medium what happens to the speed of the sound, that we are going to study in this subtopic. Next, after that, we are going to come to how do we detect sound. So what are the ways of detecting sound? Okay, first of all, are there any sound which cannot be detected or which cannot be perceived by somebody? Okay, so that type of sounds are also there which cannot be perceived by humans. Okay, but maybe that can be perceived by some other animals. Okay, so that also we are going to study in this topic. Okay, then we have next one is how one sound differs from another sound. So sound also can be of different types. Okay, so there can be different quality of sound. There can be different types of sound. Okay, there can be a low pitch sound. There can be a high pitch sound. There can be a loud sound. There can be a low amplitude sound. So various types of sound we are going to study. Basically, in sound, if you want to categorize into categories, okay, sound can be classified broadly into something called pleasant sound or music, you can say, and second is something called noise, okay, which is not desirable. Okay, so noise and music are the two extreme types of the sound. So what are the different types of sound that we are going to study in this particular subtopic? And last but not the least, we are going to study what are audible and non-audible sounds. Okay, so that's all we are going to study in this particular chapter, time being. And now coming to the very first topic, that is cause of the sound. Now, what can be the cause of the sound? Now, we have been studying sound in our earlier classes also, and we have come to know at least that the cause of the sound is nothing but a vibration. If any body starts vibrating, okay, then there are chances of a sound being generated. Okay, so one of the main causes of the sound is vibration. Okay. What is vibration? Vibration is the movement of a body in a to and fro motion. Okay, from you know one point to another point, then from that point to again the same point, that way. Okay. It is also many a times known as oscillatory motion. Okay, so the cause of the sound happens to be a vibration. A vibrating body produces sound, definitely. Okay, this we have been studying since earlier classes. Vibrations are not visible. You cannot see any vibration because particularly they are very small and they are very fast, so you cannot see them. They are not visible. Okay, Therefore they are called disturb, and they are also called disturbances. So remember, this vibration in general is also known as a disturbance in physics. Okay, so whether you call it a vibration or whether you call it a disturbance, both have almost the same meaning. Okay, so these vibrations or disturbance are always small and they are very fast, and therefore they are not visible, right? But there are other ways of detecting the vibration that we are going to study. Now, vibrating body transfers its disturbance or its vibration to the surrounding air. Okay, so suppose some body, okay, suppose there's a metal strip or there's a anything, any object, suppose that object is vibrating, okay, and suppose that object is surrounded by air. Okay, so what will happen? The vibrating body will create vibrations, and because of the vibration, the disturbance or vibration will be thrown into the surrounding. Because it is surrounded by air, so this vibration will be transferred to the surroundings. So the surrounding is air, then the vibration will be transferred to the air, which in turn will pass it to the our eardrums. Okay, so these vibrations, okay, will be transferred from air to our eardrums. Now, our eardrums are located inside our ears. Okay, so the vibration will reach inside the ears and it will hit the eardrums. That is how the vibration, which has started from the vibrating body, will be transferred to the air particles, and from the air particles, it will be transferred to the eardrums. Okay. Now, when this vibration reaches eardrums, okay, the eardrums now starts vibrating, okay, and this vibration that is created in the eardrums, okay, that is sent to the brain, okay, by a electric signal, okay, and that is a biological mechanism that every human being has, okay. So eardrums are supposed to send the signals of this vibration to the brain, and brain is going to recognize it as a sound, okay, or whatever it is, right? So our eardrums, and we can hear them. Okay, so the disturbance is sound here. Whatever disturbance or vibration that was created by a vibrating body is nothing but a sound over here, right? So this is how the sound is transferred from its source, from where it is originated, from a vibrating body, to the person's ears, the eardrum, and that is how a person, he understands that yeah, sound has been created, generated. He or she can hear that sound. Okay. So that's how sound is created or generated, how sound is transferred or it is moving from one place to another. And that is how any human being or any animal for that matter will receive that vibration through the eardrums, and it will be pursued by the brain of that particular animal. Okay, so that's the story of sound so far. Now moving ahead, let us come to this stage, that is the pattern of vibration. Okay. Now this vibrating body, okay, is going to vibrate, but it can vibrate in different ways. Okay, there can be different pattern created because of the vibration. Okay, because it all depends upon the shape of the body, it all depends upon the amount of vibration that is taking place in the body. Okay, so there are many factors that is going to decide the pattern of the vibration. So this pattern of the vibration, okay, will change if the pitch or the loudness of the sound changes. So वाइब्रेशन का जो पैटर्न होता है, ओके, पैटर्न ऑफ द वाइब्रेशन, shape, size of the vibration. Now this vibration, let me tell you, at this stage, sound vibration is considered to be in the form of a wave. Okay, you can form of a wave, right? So we are coming to that. So this wave formation is nothing but a pattern. Now this pattern, can be changed if you change the pitch of the incoming sound, or if you change the loudness of the incoming. Okay. So basically the pitch, the loudness, these are the features of any sound. Okay, you can always change these features. Okay, so when you change the feature of this sound, the wave ka jo shape hai, the size hai, the pattern, it keeps on changing. So that is very important thing that we are going to study ahead. Okay. Now coming to the next point is, what are the examples of the sources of sound? Now let us try to understand this A, B, C, D, E, some listed out examples. Okay. So you'll come to know how sounds are created by vibration by different objects. Okay. So the very first one, A part, is a tuning fork. You know what is a tuning fork? Tuning fork is a metal ka U-shape object made up of solid metal. It has a stick like this, okay, that is made of a metal, and you have a handle sort of thing over here to hold it. Okay, this is tuning fork, right? Now this tuning fork, it is made up of metal, okay, and this U shape, this U shape object, when it is banged on a rubber pad. Suppose you have a thick rubber pad over here, okay, to bang it on in, what will happen? These are the two arms of the tuning fork. Okay? So when you hit this tuning fork hard on this rubber pad, what will happen? This particular arm, any one of the arm, will start vibrating. Start vibrating this way. Right? Will start vibrating fast. Right? So this is how vibration is created when a tuning fork is hit on a rubber pad. Okay? So when a tuning fork, by hitting the prongs, now these are known as the prongs, okay, you can say in general arms. So these prongs of the tuning fork, when they are hit hard on a rubber pad, this creates a vibration, and hence sound is created. You know that any vibrating body creates sound, so sound will be created. You won't be able to hear that sound very clearly, but then if you amplify that sound, okay, or you do some mechanism to see that you can hear that sound nicely and loudly, then you will definitely come to know that on banging this tuning fork on the rubber pad, vibration will start taking place in one of the prongs, and the sound will also be generated. Okay. Let me tell you one more thing. On every tuning fork, there is some numbers are printed like 440, 340, 300, 200, whatever. Okay. Some numbers are always printed on this tuning fork. These numbers, they tell you about the frequency of this tuning fork. What is frequency? Frequency is in 1 second how many times this particular prong is going to vibrate. Okay. That is known as the frequency. So there are certain tuning forks which will have the frequency of 440. There are certain which will have 340. There are some other which will have 200. Okay. So you will find tuning fork of different frequencies. Those frequencies are always printed on them, and that will tell you that okay, when you bang it on the rubber, so if it is 441, then in 1 second 440 uh, vibrations will take place. It's 340, 340 vibrations will take place. So that's the meaning of this tuning fork, right? So tuning fork is an object which can always be used to create sound. Next is bell. You can consider it as a temple bell or church bell, a very huge one, right? Now, when you hit the bell with a gong, or the gong of the bell, when you hit with a hammer, sorry, so when you hit with a hammer, the gong of the bell, when you hit with the hammer, sound is generated. Normally, the gong is made up of a very sonorous metal, okay, like a brass or something like that, and you have a hammer which is banged on this gong. Okay, so when you bang this gong with the hammer, okay, the metal will start vibrating, and as a result, a huge sound will be created. Okay, so that is how the bell, they are used for creating sound. Hammer onto the gong of the bell can create sound. That's second example. Third is a example of a insect called cicada, whether I'm pronouncing right or not. Cicada, Cicada. Cicada is a tiny insect, and it's so tiny but then the sound that it makes is so irritating and it's so loud, that if it happens to enter your room or your house, okay, it hides somewhere in the corner of the room. You will never be able to find out where it is hiding because it's a tiny little thing, right? But then the sound that it creates because of the certain mechanism in its body, okay, that sound is so irritating, so loud, you won't be able to sleep whole night. Okay, so these are those insects called cicada. Okay. So these cicada, which are tiny insects, they make loud sounds, okay, particularly during the night time, okay, due to the vibration of a ribbed membrane. So this cicada, they have a ribbed membrane, okay, just at the base of their abdomen. Okay, so the base of the abdomen, they have this particular ribbed membrane, and this ribbed membrane, somehow they vibrate it so fast, and because of that vibration, sound is created, and that is the sound of a cicada insect. Very irritating. Okay, so that is another example of vibration creating sound. Coming to next, that is D part. It talks about the vocal cords in the human throat. Now we human beings, in our larynx, that is somewhere in the throat region, we have a organ called larynx. Okay, just below the pharynx, we have something called larynx. Now larynx, they have a muscular flap like thing. Okay, a couple of muscular flap, something like this. Okay, have a couple of these muscular flaps. These flaps, muscular flaps, are known as vocal cords. So when the air is passing, okay, in the upward or downward direction, okay, through this vocal cord, okay, when the air is passing, these vocal cords, they vibrate. Okay, so depending on how much air you are allowing to pass through the vocal cord, or how fast you are allowing that air to pass through the vocal cord, depending on so many factors, the vocal cord will be vibrating in different patterns, and different types of speech can be created. That is how, the human beings, now right now I'm talking to you, so it's just because of the movement of my vocal cords in my throat. So that's another example of vibration created by, I mean, sound created by vibration. Last but not the least, let us talk about this E part, and that is musical instrument. Now, we in India at least have so many musical instruments. Okay, there are musical instruments of various types. Basically, you can classify these musical instruments into something called string instruments. Now, string instruments are musical instruments which make use of a metal string. Okay, an example is a guitar, or a violin. So these are nothing but using metal strings. Okay, so when you pluck these strings, okay, uh, you, you happen to make a vibration in that wire on the string. That is how, the sound is created, and these are beautiful sounds. So string instruments are one type of musical instrument. Then you have something called wind instruments. Now in this wind instruments, in this category, you are going to make use of the wind. Okay, and the wind column, that is manipulated. Either you create a lengthy one or you create a shorter one. These wind columns, when you create by blowing wind from your mouth, okay, into the instruments, okay, you can play beautiful music out of it. Okay, so these are called wind instruments, and the example is a flute and a trumpet. These are making use of the vibration of the air column inside the. Okay. Then you have something called percussion instruments. Now, percussion instruments are anything which are banged. You have to bang on them. Piano is a percussion instrument. Piano, what happens is you strike with those keys, piano keys you have on piano. piano keys. So when you strike those keys, you are striking on the this thing. So this is a percussion instrument. Even tabla or the drums, this tabla and drums are having a sort of a membrane, leather ka membrane is fixed on a hollow uh, drums. Okay, so these tabla and drums are percussion. You have to bang them to create the vibration in that membrane. Okay. So these are all the various examples of how the sound can be created using vibration. There are many other, but these are the few I mentioned in the book. Okay. So let us try to answer these questions so far what we have studied. Okay. Question number one is, what are all sounds caused by? The single word answer is vibration. Simple and clear. Okay. All sounds are caused. Question number two is, a drum, a flute, and a violin all play a note, musical note. For each instrument, state what vibrates to create the sound. Okay. So for drum, what is the vibrating thing that is creating sound? For flute, what is it that is creating sound? Violin, what is it? So for drum, as I told you, it is the membrane on the drum which vibrates on banging it. Okay, not banging actually, playing it. Then in the flute, it is the air column which you manipulate. Okay, how much air you have to blow into the flute, that depends on many things. So you can manipulate the length of the air column. That is going to create sound. In flute, it is the air column, and in the violin, it is the string which you have to, you know, not plucking the string, but you have to move something on the string, and because of that movement of that something on the string, you can create beautiful sound. Kind of plucking only. So violin may, it is the strings which are responsible for creating musical note. That was question number two. And number three is describe how a drummer hitting a drum leads to a listener hearing a sound. So this is a short description you have to give for drummer who is hitting the drums and listener who is hearing the sound. So entire process you have to explain. So drummer hits the drum, and in the process what happens, the membrane of the drum, that's vibrating. So membrane vibrates. When the membrane vibrates, sound is produced. Obviously sound is produced, and this sound is transferred to the air, because when you play the drum, the drummer and the drum is surrounded by air. So the vibration created in the drums are transferred to the air particles. These air particles will reach the eardrum of the listener. Okay, so air particles, they are moving, so they will move along with the vibration carried from the drum. Okay, and that vibration will reach the eardrums. Now eardrums receives the sound or the vibration produced from the drum by the drummer, and this transfers a signal to the brain. Okay, so the eardrums will transfer electrical signals to the brain, and the brain is going to sense the sound produced by the drum. So this is the entire process, or you can say the flow chart sort of, which explains you what happens and how the drummer hitting the drum is perceived as a music or sound by a listener. Okay, so that was the answer for number three. So that's all about part one of this particular chapter. That is, what is the cause or what is the main reason behind the uh, sound being produced. Okay. Now, once we have come to know like how a sound is produced, basically with the help of a vibrating body. Now let us talk about how a sound travels. Okay, so sound is produced that we have seen. How the sound travels, what is the mechanism of traveling of a sound? So let us come to that part. Subtopic 2 is, how does a sound travel? Coming to that, sound is an energy. As I told you in the beginning only, sound is an energy like any other energy, light energy, electrical energy, magnetic energy, okay, many different energies. So sound is a kind of an energy, and it is comprised of a series of vibrations. So when a series of vibrations are created, okay, by some way or other, okay, sound is generated. Okay, so sound is an energy which is a combination of collection of a series of vibration. You can say that. So these vibrations, are passing through the medium. Now these vibrations, they wherever they are created, that particular surrounding is medium. Okay. Suppose the sound is a series of vibration is created at the water by say some animal like a dolphin or a shark fish. Okay. Then the medium happens to be the surrounding, that is the water, right? So water happens to be the medium in that case. Okay, so the sound produced by the marine animals like the dolphins and whale, okay, are traveling through a medium which is water. Okay. Now suppose a lion is roaring, okay, or when a person, well, like we people are talking, okay. So when we talk, we are surrounded by air. In our case, when we talk to each other, that is the medium in that case is air, isn't it? Now it can be some solids also. Okay, so suppose you have a solid rod, okay, and on that rod, on one side of the rod, if you are banging with something, other end of the rod, because it's a solid metal rod, okay, the sound will be traveling all the way from this metal rod. Okay, so solids also, the this thing can travel, okay. So vibration can pass through any medium, and the medium can be either liquid, solid, or a gas. Okay, fine. Now, one more thing, let me tell you here. Sound is a energy, okay, which I told you earlier that it travels in the form of a wave. Okay, and we are going to study in the subsequent chapters regarding the properties of the waves. Number 14. The properties of the waves, we are going to study more about the waves, what different types of waves and all that. So that we will be studying, revisiting this sound. Let me tell you here itself that sound waves, are of a longitudinal type. Sound waves are termed as longitudinal waves. Now, these longitudinal waves, okay, there are another type of waves which are known as transverse wave. Sound is not a transverse wave, it's a longitudinal wave. Okay. And these sound waves, they always, invariably, they require a medium to travel. If there's no medium, it's not going to travel. Okay. So sound has these two main property. The wave is longitudinal and it requires a medium. Yeah. Now, based on this, whether a wave requires a medium or not, okay, the waves can be classified into two, that is mechanical wave and electromagnetic. So the waves which require, invariably they require a medium for traveling. Okay. Such waves are known as mechanical waves. So the sound is essentially mechanical wave because it always requires a medium to travel. There's no medium. No medium means vacuum. So where there is no particles, where there is no medium, okay, such a situation is not good for the sound to travel. Never ever travel. And this is the reason, whatever is happening in the sun is a huge, very huge body, that, and there's a lot of explosion taking place in the sun. Okay, we are able to see what is happening in the sun, or we can at least see that the sun is every day coming into the sky and it is setting and all that. We can see the sun, but somehow we cannot hear any sound from the sun. Why we cannot hear any sound from the sun? Reason is sun and the earth are placed very far away from each other. Okay. Second thing is, uh, after the earth, I mean above the earth, you have certain atmosphere. Above the atmosphere, then space starts. And if you go higher and higher, closer towards the sun, the space becomes more and more, you can say, vacuum sort of thing. So there are no particles, nothing over there. Okay, you won't find a single gas or single air particles, nothing. Okay, so it's something which is termed as vacuum. So vacuum is something which is very next to the sun. So whenever suppose a sound is being created in sun, the sound first will have to travel through the vacuum. But because a sound is a mechanical wave, it requires a medium. It cannot travel through vacuum. So the sound cannot travel that vacuum. Okay, it cannot travel through that vacuum. And that is why the sound, and it cannot start only from the sun, and forget that it is reaching earth, and we can hear the. So that's the reason, like we cannot hear anything, any explosion, any sound, the sun far away, because basically sound cannot travel in vacuum, right? So mechanical waves are the waves which always require a medium, and sound is a mechanical wave as a medium. These are the two things which I did not want to miss out. You'll be revisiting these things in that chapter number 14. Now, vibrating body produces sound, or you can say vibrations, which are moving backward and forward. Now, these vibrations, I told you this vibrating body, when it vibrates, the motion is to and fro. Okay. Suppose you have a prong of tuning fork, and if you hit it with a rubber, if you hit it hard on the rubber pad, what will happen? This particular prong will vibrate this way. It is going to vibrate in the forward and in the backward way. Okay. It's going to shift between these two places. These are known as extreme positions, right? So this prong of the tuning fork is vibrating forward and backward, forward and back, forward and back. This type of a motion known as a vibration motion. Okay? So when this vibration takes place in any body, this is how the motion takes place. This in turn makes the air particles move backward and forward. Now, because of this movement of this prong, okay, the air particles, okay, now this is the neutral position of, okay, now the air particles which are surrounding, okay, air particles are also going to move forward and backward because of the movement of this prong of the tuning fork, isn't it? Or for that matter, any body. When it is vibrating, the surrounding particles will be definitely affected. They will also vibrate in the same way. Okay. So the air particles, they move backward and forward in the direction of the path of the sound, and these air particles, they will vibrate such a way that the sound will travel in that direction. Okay, so suppose the sound is traveling in this direction, the form of a wave, then the vibration is also passing in this direction. So basically, the direction of the uh, movement of the vibration is considered as the direction of the movement of the sound. Is that clear? Now, there are a series of vibrations from a wave called sound wave, and these are longitudinal waves. I just talked to you about longitude. Sound is a kind of longitudinal waves. Now, squashing and stretching are the something which is causing the wave to travel forward. Now, what is this squashing and stretching? What happens is, suppose the object is moving and it is coming in this position. Okay. In the process, what happens? The air particles here, they are squashed. Squashed means they are brought near to each other. Okay. They are compressed together. So a region called compression is created, denoted by a C. Okay. Now this particle is going. Now this body is going to vibrate and move in backward direction. Now when it moves in the backward direction, what happens? The pressure here is released. And this particular compression is going to move ahead, going to come in this, and in the place of this compression, now you will get a rarefaction known as rarefaction. denoted by a R. Rarefaction is a region where the particles are relaxed. They are far away from each other. They are not squashed. Okay, so squashing is something where the particles are very close to each other. Stretching is something where the particles are relaxed and they are far away from each other. Stretching is termed as rarefaction. Rarefaction. Here I have written rarefaction. Okay? And this squashing is something which is known as compression. So this squashing causes compression and the stretching causes rarefaction. This compression and rarefaction, they are alternately, moving in the forward direction. Whatever direction the sound is moving, that same direction this compression and rarefaction are going to move ahead alternatively. Okay. So this is how the sound energy is moving. This is how the sound travels. That clear? And one thing is very important, because you have seen the mechanism now. Particles are essentially required for this thing to happen. Okay, that is creation of the compression and rarefaction. Compression and rarefaction are nothing but a situation created by the particles. Okay, so there are no particles. There's no way that your compression and a rarefaction can be created. Okay, so that is the reason sound is a energy which is termed as mechanical energy. Mechanical wave, and it requires a medium essentially. So we have talked about compression and rarefaction. Now let us talk about sound requires essentially some or other medium. Now, because of all this explanation, now it will be clear to you that because of these reasons, sound essentially requires some or other medium. Okay. Without medium, it cannot travel. Sound cannot pass through vacuum. Why it cannot pass through vacuum? Because vacuum doesn't have any particles. Okay, so it is a no medium situation. So if there's no medium, sound will not be able to travel through it. Vacuum, the sound cannot pass through vacuum because it has no medium. Okay, no particles. Now there's a bell jar experiment which will help you in proving or in showing that a medium like air is mandatory for the sound to travel. And sound can travel in all the three mediums: solid, liquid, and gases. So these are the things which we are going to continue in the next video, that is the bell jar experiment, and how sound travels differently in different medium, in solid, liquid, and gases. How the sound travels, what is the speed, the speed of the sound affected. Okay, so all that we are going to study next video. So that's all for this today's video. We have just started with the introduction of this chapter. Bit of things have been discussed in this chapter. If you happen to like my video, please subscribe my channel, that I will be motivated to make uh, more and more topics, okay, on IGCSE. Okay, so that's all for today, and thanks for being with me. Bye. Take care.